Hi guys, welcome back to my YouTube channel. In this video, we are going to see about a simple electromagnet. Let's start. Here is a simple electromagnet setup. I have taken one iron nail wounded with a copper wire connected to a cell. One end I have connected, another end just I have left it. I have taken this type of iron nail because iron is the magnetic material for electromagnet. Electromagnet will act as a temporary magnet. So for making temporary magnets, iron or mu metal is the material. If you find this kind of pure iron, it will work perfectly both magnetization and demagnetization. Let me explain in brief how does this electromagnet works. As you all know from previous videos, when a current flows through copper wire, it experiences a magnetic field around that wire. When this copper wire is wounded into this nail, this magnetic field produced due to current in the wire induces magnetism into this nail, and this nail acts as a magnet. It only behaves as a magnet when there is a current flow through this wire. Right. So let's do our observation. Here I have taken some paper clips. Now you can see nothing happening. We are going to observe by connecting this wire to this end of the cell. Then the current will be flowing through this wire and it induces magnetism into this nail, and it acts as a magnet and it attracts a magnetic material. Are you ready? Here we go. Yes. So you can see the paper clip is now attracted to this electromagnet. Now this is magnetization. When we remove the current from this wire, suddenly this paper clip will fall because this iron nail get demagnetized, or this iron nail loses its magnetism. Are you ready? I am going to take my hand. Let's see. Ready? 1, 2, 3. Yeah. So when current flows through this copper wire, this iron nail become magnet. That is, magnetization take place. Soon after, when remove the current, it become demagnetized and it loses its magnetism. Let's try again. Okay. I'm going to remove. Yes. So this is how the electromagnet works. In two ways we can increase the strength of this electromagnet. One is by increasing the number of turns in the coil. Another one is we can increase the current in this circuit. In this both way we can increase the strength of this electromagnet. I hope you enjoyed it, you got it. Let's try few questions from electromagnet. Try this first question. Which metal is suitable to use to make a permanent magnet? Option A, aluminium. Option B, brass. Option C, iron. And option D, steel. Your time starts now. The correct answer is D, because this aluminium and brass are non-magnetic material. As we are discussing about electromagnet, the iron is the best magnetic material for electromagnet, that is temporary magnet. So steel is the permanent magnetic material. Try this second question. A strong electromagnet is used to attract pins. What happens when the current in the coil is halved? Option A, no pins are attracted. Option B, some pins are attracted but not as many. Option C, the same number of pins is attracted. And option D, more pins are attracted. Your time starts now. The correct answer is B. Because no pins are attracted means there shouldn't be any current. Look at option C. The same number of pins is attracted, not possible because the magnetic field strength can be increased by increasing the current in the coil. By decreasing the current that is given here, the current in the coil is halved, means half it is decreased. So it must attract the pins less than before. So some pins are attracted but not as many. So the option is B. Try this last question. An electromagnet is used to separate magnetic metals from non-magnetic metals. Why is steel not suitable as the core of the electromagnet? Option A, steel is a good conductor of electricity. Option B, it has a high density. Option C, it has a high thermal capacity. And option D is it forms a permanent magnet. Your time starts now. The correct answer is D, because it forms a permanent magnet. Iron is the temporary magnetic material. So steel is a permanent magnetic material. So the answer is D. I hope you got something about simple electromagnet. You can try this at home and learn through your experience. Thank you.